Good day, this is Luella Maraya Aquino and I will be discussing about the partial counterbalancing. So, what is partial counterbalancing? So, the basic idea of partial counterbalancing is the same with the complete counterbalancing. So, we use partial counterbalancing or this procedure when we cannot do complete counterbalancing but we still want to have some control over progressive error across the subjects. So, partial counterbalancing controls progressive errors by using the sum subset of the available order sequences. So, those sequences are chosen through the special procedures. So, there are three types of partial counterbalancing. So, the three main types of partial counterbalancing or three across subjects in partial counterbalancing are: first, the randomized partial counterbalancing. Second is the Latin square counterbalancing. Third is the balanced Latin square counterbalancing. So, what are the difference between the three? So, the first is the randomized partial counterbalancing. It is the simplest type or form of the partial counterbalancing. So, each subject is given a different random order of condition or trials. So the first is the randomized partial counterbalancing. It is the simplest type or form of the partial counterbalancing. So, each subject is given a different random order of condition or trials. So, randomized partial counterbalancing is used when the number of condition or the trials are far larger than the number of the subjects. So they get it randomly from the root word random or root word or the word random. So the second is the Latin square counterbalancing. So it is presenting a subset of condition orders such each condition appears once and only once on each position. So, it is here. The example will be here. So, this is the example of the Latin square counterbalancing. So, the number of subjects required is equal to the number of conditions. So, yan, as you can see here, the number of subjects and the number of condition is the same. So, 5 subjects, 5 conditions. So, in this case, there are 5 condition and there are 5 subjects. So, the third type of partial counterbalancing is the balanced Latin square counterbalancing. So, same as above with the additional restriction that any condition comes before or after any other condition an equal number of times. So, in the balanced Latin square can only created when there are an even number of conditions. So, as you can see the example here, so there are 4 subjects and 4 conditions. So, 4 is an even number. So, it is restricted that the balanced Latin square counterbalancing is looking for the even number. So, I will be showing you later on how to construct a balanced Latin square counterbalancing. So, let's watch.
Good day. This is Luella Maraya Aquino and I will be discussing about constructing a balanced Latin square counterbalancing design. So, while a Latin square ensures that each letter appears an equal number of times, it doesn't protect against order effects. For example, in above 3 by 3 example square, treatment B follows A 3 times in a row. It follows Z in 0 times. A balanced Latin square evens out what follows what scenario because it protecting against order effects. If you have an even number of experimental conditions, constructing the square is very easy. As I have said earlier, even number is important for the balanced Latin square design. So, in making the square, the following algorithm can be used to make a balanced square for an even number of testing conditions. So, as you can see in the yellow highlighted part, this can be this these numbers are the one that we are using or our reference in doing the square. So next, for example, make a balanced square design for 6 participants. So A, B, C, D, E, and F with 6 testing conditions. So step 1, making the first row using the formula. So our formula is 1, 2, n. So our n is number 6 and 3, n minus 1, and n minus 2. So 1, 2, C, 6 as our n, fourth is the number 3, fifth is n minus 1 is equal to the 5 because 6 minus 1 is equals to 5. So the sixth is n minus 2 and the 6 minus 2 is equals to 4. So the step 2, fill in the first column sequentially. So the step 2 is you should fill out the first column in order form. So the last step is the step 3. Continue filling in the columns sequentially until the square is completed. So we will start from the second column that also start in the number 2. So 2, 3, 4, 5, 6, and 1. The third column starts with the number 6, which is our n. So 6, 1, 2, 3, 4, 5. And the fourth is the number 3, 4, 5, 6, 1, 2. The fifth is the n minus 1, which is 5. So 5, 6, 1, 2, 3, 4. The last and the sixth column is n minus 2. So 4, 5, 6, 1, 2, 3. A completed balanced square design with an even number of conditions. So for an odd number of conditions, making the balanced square becomes a lot more complicated. The experiment will become more time consuming and expensive. Each participant must be tested twice for each condition. Doubling the number of treatments given. For example, if you have 5 treatments, participant A might be given 1, 2, 3, 4, 5, and so on and so forth. So the references is experimental psychology,